This is the general scheme of the proposed solution for the Kit for SME project. The proposed use case deals with the safety of workers in industrial environments, more specifically with the monitoring of suspended particles in work areas. First, we will show the device used to measure the data. The device used for particle measurement in the laboratory is shown here. This device consists of the board in charge of data measurement and an edge node connected to the FogFlow framework, where the artificial intelligence functionalities will be carried out to obtain the state of the air quality and a forecast for the next hour. An MQTT server is deployed in the processing node, which is in the same encapsulation as the sensor, to receive the data from the sensor, and by using the FogFlow graphical interface, the rest of the services that will be deployed in the edge node are configured. This is the graphical interface of FogFlow. Here, you configure the rest of the services that will be automatically deployed on the edge node as soon as data from the sensor is received. Here are the running tasks that have been deployed in FogFlow. First, a task has been deployed to transform the data received at the MQTT server into the NGSI format used by FogFlow. This is the output entity returned by the first operator. It is an entity in NGSI format that contains the data reported by the device, which are the measurement date and the PM10 and PM2.5 particle values. The output of the previous task serves as input for the artificial intelligence function, which returns a quality assessment of the reported data and a quality prediction for the next hour. Here can be seen the output entity of the artificial intelligence function. It contains an analysis value of good or bad according to the recommendations of the World Health Organization and a prediction value for the next hour according to the artificial intelligence calculation. Lastly, a final task that transforms the data into NGSI LD format and sends the output of the previous tasks to the Orion Context Broker deployed in Kit for SME. Once the data is in the Kit for SME platform, the next step would be to display real-time data in a visualization tool. Here is the NGSI LD format entity within the Orion Context Broker, which contains both the sensor's value and the artificial function's output. The next step is visualizing the subscription created in Orion to send the data to Quantum Leap for storage in a time series database. The last part of the demo consists of visualizing the data, for which a dashboard has been designed using Grafana. The design dashboard is shown here. At the top left of the dashboard, the current air quality status is displayed by measuring suspended particles, and below that, the forecast for the next hour. In the central part, the values reported as a function of time are shown as historical data. This shows the count of reported and predicted values in the selected time frame. On the right, we show the good and bad values reported by the artificial intelligence function as a solid line, while the prediction values are shown as a dashed line. Finally, we have each particulate matter, PM10 and PM2.5, and a history of the reported values separately.
Behind the change, beyond the challenge.